All right, we're back. I kicked my computer, like a slow person. Don't be like me. Moral of the story: kicked my computer. Kicked my computer. That was so depressing. But we take our break for a reason, and we're gonna come back stronger than better than ever. Disrespect. What's happening? The Fiend Kettleware. How did we know? This is how they play. Yo, this guy is just weakening the hell out of his king side. Surprisingly enough, I didn't actually mean to do that. That was so retarded. Lost my beautiful graph. Why is there a node 7, bro? Okay, do we want to go from node 2 to node 4? Obviously, we go to. Oh, there's two different weights. That's kind of annoying. So we go. What are only 2 to 6 is 8, and yeah, 6 to 8 is 2 is 8 is also 16. So what happens here? Oh brother, that got really ugly. All right, well, we're gonna have to put this on another monitor. So it says we go from node 2 to node 6 for a cost of 8. That makes sense. And then we go to node 5. 6 goes to 5 for a cost of 1. Is that true? Because we went from node 6 to node 5. Mother, what? Yeah, 6 to 5 for a cost of 6. That doesn't even make sense. That legit does not make sense. Oh, I know. One stop. From 2, we go to node. Yeah, from node 2, we go to node 5. Okay. And then we go to node 0. For a cost of 10. And then we go to node 2. Did we just make a fucking loop? What? What? We went to node. Did we just go back to node 2? That's a little not cool. Hey, yo, it literally says we went to node 4 with a cost of 16. But that's 2 stops? Like, wait, what? It says we went to node 4 where a cost of 16. Isn't that what we want? The cost of 19 isn't even here. All right, there's like a huge error. Like that's like how do we have an output of 19 equals 19? I don't know. I think we just need to return the cost. What's the difference between returning cost and returning price at node at cost? Because the node would be 4 and the stops would be whatever stops is at. Yeah, that's kind of weird. Asking the same question nobody would help you think. Wait, to know. Oh shit. 5 push-ups? Alright, I got you. Damn, so that's actually pretty easy. It actually helped me. Nice. We're actually able to get the answer here. So it seems like not sure. Even though we were able to get the answer, I should see what's the difference between returning cost and returning our price array at that cost. I assume they would be the same. Hmm. Right before we return, let's just print. Print our prices. Then we want to print. Store 2 things. So that'll be node and steps. Try this. It's not step stops. Okay. Solution. Do we have a lambda function? 3 and 2. Okay, wait, no, wrong. This is definitely the wrong one here. So we had 4 and it has a cost of 2. I even have the graph visualized here because we went from 2 to 6 to 4 for a total cost of 18. So the steps would have went 1 stop and then 2 stops. So what's 4 and 2? I guess that's really what I'm trying to figure out. Why is 4.2 different from the total cost now? Did we not update it? To the price at neighbor and stops. This neighbor should have been 4, and the stops should have been 2. That is so interesting. This is wild. If anybody in the chat understands, I gotta do that guy's push-ups. Give me a second. Uh, hmm. Getting to node 4 under 2 stops. Is there another way that would cost? Which path would cost 19 to get to 4? So from 2, we have 3 options: 0, 5, and 6. Obviously, this is the cheapest. If we go to 0, this doesn't seem very. I can't see what this edge is. What's 5? What's this? Is a double directed? It should be on the other side if there's 2 of them. But going from 2 to 5 must cost 9. It does. So 2 to 5 costs 9, and then it goes from 5 to 4 with a cost of 19. Hmm. That's interesting. My map has node 4 with a total step count of 2 set to 19. Now you're going from 2 to 5 to 4. Should have went from 2 to 8 first. That's so interesting. I don't think I understand why that would happen. Hmm. This should have been overwritten, no? This most. So when we were at 6, that's 1 stop. The neighbor would have been 4 for 2 stops, and the new cost should have been 16. Neighbor and the step count. Oh. Oh my god, I get it. We we're not even comparing the same thing. After we realize that we're not over k steps, we need to say stops plus equals 1. And now I think returning, this should fix, I believe. Okay, we got this one wrong now, which is not that big of an error. I don't think, at least not yet. That means we never hit this case where we. What's wrong here then? So for neighbor, price, and GCAD node, if the new cost, do a P. Oh no, we can't do that, because that would infect the stops for everything. Stops plus, we just have to do +1 everywhere. This would make more sense. Yes, nice. So we should just be able to return what we did before. So price at node n. stops. Come on, come on. Should work. Yay. Okay, that was actually that was a fun lesson. Let's ask ChatGPT. What does it think about my solution? I do have a question about the price table. Hmm. But yeah, yeah, we could have done that as well. Use another. Oh, something else. $8.47. Have I solved this? Yeah, I'm doing a hard problem. 2200 rated difficulty. Guess we're doing this. Undirected. You have undirected can. I'm gonna go pee. I'll be back. 5 minutes. Hmm. Transition. The shortest path. I think like we just ran Dijkstra's on it. Maybe just, hmm. First thing thought is to just was to brute force it, like starting at each node and then traversing until we reach all nodes. But we can reuse nodes, so we can't say like if we go from 0 to 1, we can go back. Hmm. How do we make sure we don't go in an infinite loop? Because if we go from 0 to 1, 1 obviously you can go back to 0. But how do you make sure it doesn't go back to 1? Maybe. Just continue this. 2 to 3 would cost 2. Who's passing? I think I got the answer. All these. Okay. I actually think I can solve this. It doesn't work for this example. Store these things. Dike. I just call it like Dike. Oh, distance in the node. What's the distance in the node? Then what? Run. It's crazy. Don't compare it. DYKS. DYK. DYK. Why is the answer 0 if the path has clearly has like 5 traverses through 5 nodes? Are we just like that's a little weird? Understand that? Sure. If this is the length, if this is the path, isn't the length clearly 1, 2, 3, 4, 5? Unless you're just going Length 0 index, maybe? Is that what they mean? Yo, I need to ask ChatGPT, like, is the answer 4 if the path is length 5? Like, what? An edge is only counted once. Okay. Brother. So does my algorithm even work anymore? Mm-mm. Brother. I think we're gonna have to run Dijkstra's on every single node. I think we're close, kind of. We need to revisit this. There's no weights. What are we comparing? What's up, man? We are. This is a bit of a difficult problem because we're using Dijkstra's algorithm, but there's no weights. Leetcode 7 847. 0 to 1. Maybe this was like smart. Does this work here? Let's say we started like, I don't know, 0. So it's a 0 to 1 cost. So 0 to 1 costs. Say, hey, how much does it cost to go from 1 to 2? I would say how much it costs to go to 2 to 4? God, that's actually insane. We'd have to calculate every single like possible way. 0 to 1, 1 to 2. But if we went straight to 3, this would cost an additional 1. Then to get them from 3 to 4 would cost 2. 2, 3, 4, 5. Kind of like depth for a search, maybe? It was very tricky. We ran a DFS on this. It's undirected too, so like, going back is crazy. I don't know. I don't know. 0 to 1, 1 to 2. And how do you make sure 2 doesn't go back? So crazy. Yeah, that this is a bit tricky. There's no hints either. God damn. Bit manipulation, bro. Bit mask. Oh my god. I know breath for search. What? Kind of weird. Okay, so 0 goes to 1. Yeah, I don't know, man. I don't know if I want to do this. I don't know if I. Bit mass DP. I don't even know what that is, bro. Oh, I've solved this. Leetcode 1091. That problem is crazy. I don't know anything about. I already solved that too. I'm gonna have to look in the graph section. There's 179 of them. I feel like it can't be that bad. Let's go by acceptance. It is not solved. Bunch of hard problems. Maximum candies you can get from a box. Okay. You have n boxes labeled from 0 to n minus 1. You're given 4 arrays: status, candies, keys, and boxes, contain boxes. Status I is I if the ith box is open, and 0 if the ith box is closed. Keys is open case for the ith box. Keys is a list of labels of boxes you can open after the ith box. Keys is a list of labels of the box you can open. Okay. So if we open so you have to open a box, you get a key and it tells you where you can go next. Contain box is a list of boxes you found inside box I. Okay. You are given an integer array initial boxes that contains the labels of boxes you initially have. You can take all the candies in any open box and you can use the keys in it to open new boxes. And you can also use it. Wait, what? To open new boxes, and you could also, but you can also, and you also can use the boxes you find in it. Okay, brother. This, I feel like it's probably not that hard, but understanding the problem is a bit. Okay, so there's n boxes labeled as 0 to n minus 1. So it says if it's open or closed. Okay, so we only could get boxes that are open or closed. The number of candies in a box. A list of labels of boxes you can open after opening the ith box. A list of boxes you found inside the ith box. Inside box 0, you can find box 1 and 2. Now you will initially be given box 0. And you will find 7 candies in it. Okay. We open box 0. We see that there's 7 candies. In boxes 1 and 2. Are we always given box 0 in the beginning? If you're given an array of initial boxes that contains labels of boxes you initially have, you can take all the candies from any open box and use the keys inside to open other boxes. But you could also use the boxes. And you also can use the boxes you find in it. Hey. Maximum of candy. So from my understanding, you can either open box 0 or box 2 because they're both open. So open box 0 and we get 7 candies and we unlock boxes 1 and 2. Close and you do not. Zero, 1, 2. 2 you will find 4. 4 candies in it. Yeah. If I keep a box 1. And in box 2, box 1 you will find 5 candies. Yeah. Box 3. Okay. You will initially be you will initially you will be initially given box 0. Is that like a constant? So we could have opened box 2 first as well. Oh no, this is status. Oh, we need initial box. I'm so silly. Okay. Seems like a depth first search question, maybe? So maybe we're in DFS on box 0. Check our status. It's open. So we open it. Yeah, I need to draw this out. right, so we're given box 0. It's open, so that means we open it and we see what's inside of it. We see 7 candies, so we got plus 7 candies. And this box has been like looked at. In box 0, we have 0 keys, but we also get boxes 1 and 2. So our initial boxes, I feel like we should have some type of array for initial boxes, and after we open it, we like pop off the array. Seems like breadth for a search. So we add this to our queue. So like say we had a queue and it started with initial boxes, we pop that off and then we get 2 and 1. At this point, we need to, we haven't found any keys yet, so if we find a key, we just have to change the status to 1 because it's openable. And we need to store our candy somewhere. Okay, after this point, we should pop off box 1 from our queue. And we should have changed this to 1 because box 1 can now be opened. And we check and box 2 and make that 2 as well, but it's already 2. Now we open box 1. We see that there's 5 candies, so we do plus 5 to our candies, so that gives us 12 candies. We check the keys. We don't find any keys. And we say, hey, we found box 3. So we add that to our queue. I'm doing good, man. Actually, I think I'm gonna be able to solve this problem. Pretty happy about. Wait, yo, what? Keep. So this would be 12, and we find box 3, so we can add that. Next, we go to box 2. It's open. 2 has 4 candies, so 12 plus 4 is indeed 16. Check, hey, is there any boxes inside of box 2? We find 0, 1, 2. Wait, what? Wait, did I mess up something? Inside of box 2, we found 4 candies. Inside of box 1, zero, 1. We never went to 2, so how the hell did. Oh, just because we got a box doesn't mean we have a key to the box. Hold up, there's something I think we messed that up. Okay. Yo, what's up? What's up? What's up? We're about to solve this problem. Oh, if you guys want to join in, it's Leetcode 1298. If you guys are interested, I think we're gonna be able to solve it. I'm not. Wait, where's my whiteboard? It's not. I kind of messed up the math there, but I think we're gonna have a queue, and we're gonna do breadth first search through all of the boxes. And our queue is gonna start with our initial box, so we have 0. Erase this. We should check the initial box. And we see there's 7 candies in box 0. So we have 7 candies. We find 0 keys. I need to redo all this. Okay, there's an issue. I need to recopy this. Okay. All right, so we have the Q, 0, we pop off 0. Say, hey, we found 7 candies. So we have 7 candies. So this has been eaten or looked at. We say, hey, did we find any keys? We did not find any keys. So we're not opening. There's no new boxes that can be opened. And we find boxes 1 and 2. So that means we add 1 and 2 into our queue. And that's it. So now we pop off the 1. Zero, 1. Oh, wait, no, that's bad. But this is where it gets interesting. We pop off the 1 and we see that it's closed. That's the interesting part because we don't want to. Maybe we should peek the queue, and if the next box we have is closed, yeah, that's the thing. We don't want to process 2 just yet or 1 because it's closed, and we can't actually do that. Let's see what the. Yeah, we have to go to box 2 first. That's the interesting part about this problem. We can't just go straight to box 1. So how do we want to tackle this problem? We can say if the next box to be in queued is closed, can we just push it to the back of the queue? We'll pop it off. We see, hey, bro, this box is closed. That would just be an infinite loop because it'll just keep adding it to the back of the box. Maybe can we have some type of array that can store boxes that we have but don't have keys to yet? Hmm. Ooh, we can use a heap. We can use a heap. We can use a heap. That's what we need to do. We're going to use a heap and we're going to sort by open boxes. So in a heap, 2 would come. 2 would come first and then 1. Perfect. We open box 2 and we say, hey, there's 4 candies in there. So we do plus 4. 0, yeah. And that equals 11. We say, hey, in box 2, do we have any keys? We do. That means we can unlock box 1 now. The only issue is we have to access box 1 inside of our heap and change its status to openable. How do we do that? Hmm. That's the hard part. I think we're just gonna have to store our keys somewhere. Let's just say we had an array called keys. That's the only way. And we just found a key, so we're gonna add key 1 here. I don't know if it's the only way, but it's the only way I can think of right now. And box 2 has no additional boxes. So we've done processing number 2. Next, we go to 1. We pop off 1 and we say, hey, do we have the key? Is this node inside of our keys? It is. So that means we can process it. So we go 0, 1. So this is openable. So we're going to go to it. We add +5 here for the candies. So we get 16. We don't get any new keys. And we get the box 3. And we're done. So this has been fully processed. And next, all we have to do is we pop off the 3. We say, hey, we don't have this key. And yeah, because if we pop off it and we don't have the key, that's just done. We return 16. I think we can solve this, boys. I don't know if y'all still here, but I think we got this. Let me move my Excalibur draw to the other page. So we're gonna do breadth first search. No, we need a heap. A heap. Can we have more than one initial box? Initial box length. Oh wow. Okay, we can be given actually a lot of initial boxes. So we need a way to we need a heap with all status. I'm gonna say wow heap. Keys. Um, we're gonna say wow heap. Pop the pop the current node. So in this case, we get 1. Pop the current node and status. Here, do we have to? And we need to check if status of cur is 1 or cur in keys. Wait, no, we want. So you want to skip it. If we can't open it, we just want to continue. So we need to do the opposite. So if the status one is 0 and cur not in keys, then we continue. Next. That means if it passes this, that means we know we can open it. Oh, we need a candies. Okay, let's knock out one step at a time. So we want to get a heap with tuples of the initial boxes and their status. Can I do this? I think I could do. Do we have a status first so we don't status? Box, comma, box, or box in initial boxes. So this should make a heap with the status of the box for all the boxes, initial boxes. That was easy enough. To E is just going to be an array. Res is going to equal 0. Wow, heap. Heap, pop, heap. Yeah, heap, pop, heap. Heap, pop, heap. Hey, bro, great way to maintain consistency. I also started Leetcode, but not as regular. Oh, yeah, yeah. I appreciate it. And good luck on your Leetcode journey. What do I want to call this? I can just call it stat. Comma. If I just have it here, so if stat equals 0, and like something's off here. So if the stat yeah, so if the box is closed and we don't have a key for it, then we can't open it, so continue. Res plus equals candies plus wait, no, plus equals candies at node. I'm supposed to take a break right now. Maybe just a short one. I feel like I was really close to finishing this. Let's go for another 15 minutes. And then I gotta go eat lunch or something. Is it candies and plus your nose? And then we say keys that append. It's gonna be an array. We don't wanna append an array, really. How do you spread an array? I don't know how to do that. How do you spread a list in Python? Oh, there's a spread operator. So numbers spread tuple into list. It's not really what I want. Latin? What the fuck? So we just need to unpack the list. I'm not sure if this is how that works. I can do keys plus equal. Just keys at node. Something like that. And here we add the contain boxes. Contain boxes. So contain boxes at node. Box for box. And contain boxes at node. Keep push. Keep push status of the box and the box itself. And return res. Okay. Okay. Okay, the first one's right. It's not too bad. I've got 11 instead of 16. What adds up to 11? 4 plus 4 plus 7 is 11. We didn't ever add the 5. Yeah. My theory was that my theory was that we would have added box 0, then that would lead us to opening it, adding 7 candies, and getting boxes 1 and 2. Box 1 is not open. Okay. This would be very helpful. Let's find out what order we went through in. We went 0, 1, 2. That's not good. Oh. 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 We need a max heap. Silly me. We need a max heap. Wait, hold up, hold up. Because we want to prioritize boxes that are 1 first. That are like higher. Let's think about this. Let's think about this. So if you have 0 and 1, we always want to pick the higher number. So if we did a max heap, because right now we're picking the 0 first, which is no good. How do we pick the 1 first? -1 and -0. What's bigger? I want to simply. All right, what if we popped it off and we said like 0, like, and 0? This would be 1. If we said and 0 to this, it would be. Right? If we said and 0, this would evaluate to 1. If we said and 0 to the 1, this would evaluate to false, so 0. And we'd essentially get opposite. I just say and 0. Cut off stat equals stat and 0. Let me just do and 0. So that should do the opposite, right? Yo, my this is so buns. All right, clear. That's not how you do that. All right, went 0. You're supposed to go 2 first. 1 has a value of 0. So hard we're doing a max heap. I feel like it's weird because if you just multiply it times negative 0 and 1, what's lower? Negative 1, duh. Yeah, let's just make it like times negative 1. This makes so much more sense. Let's go, baby. Did we just solve a hard problem? What's up, mate? What's up, dude? We passed the regular test cases, but we crashed out on case 19. What happened here? Yeah, output 8, expected 10. Oh man, the pain. I did not mean to click that. Use test case. I think I might have to take a break after this. Missed a box. Just trying to get better at Leetcode, man. Why does this not work? What about this is like different? It's because we have 2 initial boxes. Okay. For some reason, we got 8 and we're supposed to get 10. I wish it was drawn like that, but whatever. So initial boxes, we have we're gonna have a queue, and it's gonna have 3 and 0. They're both open, so we can go to either one. Doesn't really matter. go to 3 first. Zero, 1, 2, 3. So we've been here. Candy 0, 1, 2, 3. We have 4 candies. 0, 1, 2, 3. We have keys of 2. So okay. We have a key of 2. Contain boxes. We have nothing. So we have nothing. So we're not going to add any boxes. Now we process number 0. Candies in 0 has 1. So plus 1. We're at 5. We don't capture any keys, but we get boxes 1 and 2. So 1, comma 2. And we're sorting by which one's open. Oh. Oh. Oh, I see. I see. The status is still closed. So it won't sort, right? That's interesting. When we found key 2, Keith was already messed up. That's not very good. I think it went to 1 first. Saw it was closed and then deleted itself. How can we fix that simply? As soon as we get a key and we add it to our keys, it doesn't really change. The fact that 2 is already in there, right? Box 0. Box 0 actually had what key? The first key we ever went to actually had the thing. So what if we just like what's going on? Maybe just say for K in keys at node. Status at node equals 1. I feel like we have no use unless we don't. The only problem is what if we get a key? We already added it in. Like we got the contained boxes. We added in and then we get the key later. Yeah. Ooh, zero. Zero has literally 1 and 2 as boxes. But but we literally went to three first, and three should have unlocked two. That's the confusing part. Yeah, we picked up 3. We went to node 3 first, and that literally has a key. That's an issue. This is not working. For key and keys at node, stats at key equals 1, buddy. I still don't, this will fix this one problem, but I don't think it will fix the other ones. Because we could possibly get, boxes and their status is already set inside of our heap, and then find the keys later. Like, for example, if we went in, let's say, like, I don't know, if we went to 0 first, we'd have 1 and 2. We'd have added that to our heap with the incorrect values. Yeah, it's not gonna work. I think I'm gonna need a new approach. I know for a fact it's not gonna work. Yeah. That was a good session though. I have to come back to this. I'm gonna go eat lunch now and do some stuff. Anyway. Damn, this was so annoying. We essentially need to add it to the heap. Hmm. What if we only added it to the heap if yeah, what if we only added it to the heap if it's unlocked? We get 1, 2 from someone. Let's say we go through. We hit 0 first. We get 1 and 2. They're both not unlocked, so should we add them? Maybe we should have like another array called like closed boxes and just have 1 and 2 in there. And then we go to 3. 3 gets the key. So maybe we can go and get the closed box and toss it into our heap. Yeah, right? Because like if we get to 2, we go to 3. We say, hey, is this key inside of our closed boxes? It is. So we're gonna remove it from our closed boxes and add it straight to our heap. And our closed boxes would still have 1 in it. It had 2, but we removed it. What's going on? Process 2, so 0, 1. So the status of 2 is open. Go 0, 1, 2. We add the candies. Yeah, I got you. Just give me 1 second. And then we add 1 and we say, hey, we have a key to 1. Is that a box that we have that we can open? It is. So we add that onto our heap and we get 1. I feel like that works. I'm not gonna do it right now though. I'm tired. I want to do something else. I'll do your push-ups and then I'm gonna hop off. And I'm hop back on like later. A lot of people here. Anyway, boys, I'm gonna hop off.